क्या हुआ? Equal the first term has NC zeros with one being the first term, 1 plus, and then you get NC1. Is that right? ऐसी होता है ना भाई? NC1 x to the power 1. And then what do you get? NC2 x square and NC3 x cube and so on. Is that right? This is how you expand when first term is 1. यहाँ तक clear है सबको या नहीं है? कोई बात जो नहीं समझ आई, anything that is difficult to understand? Now, there are some limitations to this method. And what is that limitation? That once, बोलो? वो ज़्यादा बड़ी पावर होती है फिर नहीं, so what? तो 10 पर मैं लगा देता हूँ plus 1 too much working? No, not too much working. The issue with this form is that I can only plug it in the calculator if n is a positive integer. For example, I want to do 5c1, then I can put 5 c and then 1. ऐसा ही है? 5c2, 5c3 and so on. But what if n is a negative number? What if n is -3, if n is -2? What if n is a fraction? Then what? Then this method is not applicable because the calculator will not give us any responses for n, c, anything when n is not a positive integer. Is that right? So let's expand the same binomial expansion for the conditions when n is not a positive integer. Okay, how do I simplify? पहले तो nc1, nc2 इसको समझो, एक तो इसका कितना पता फॉर्मूला होता है, and I'll tell you another easier method to approach this nc1 and nc. पहले इस basic method which is a part of your AS में S1 में भी आता है. Okay. Now, for example, I give you n is 12c3. Then what? हाँ बच्चों. a में मतलब 1 power 9 so बता रहा हूँ ब्रैकेट में लिख 1 power 9 प्लस के साथ ही करते हैं, डोंट वरी. हाँ बोलो. एक तो एक हिस्सा बटा फॉर्मूला. एंड व्हाट इज द अदर वे? अनदर इजियर मेथड इज you start with 12 and you write 3 numbers and divided by 3 factorial. S1 में भी आता है, and that is the easier way. So I can say that this will be plus, तो हमारे पास रहेगा 12 into 11 into 10 divided by. You start with 12, तो किसा बड़ा formula 12n into n minus r factorial upon r को जो वाला जो है. The easier way, the easier pattern observation is this: if you have a 12 series, you start with 12, you write 3 numbers in descending order, and you divide it by 3 factorial. This is just the easy common pattern. I'll just write a few more so that you can understand. If I give you 13 C4, yes. 13, 12, I'll start with 13. How many numbers do I need to write now? 4. So 13 into 12 into 11 into 10. And then divided by 4 factorial. Is this right? Now, if I give you NC3, then what? N minus 1. Very good. N minus 1, n minus 2 divided by. It makes sense. Obviously, it's the trick that you can use in S1 as well. for permutations and combinations. If in some questions they do not provide you with it, then what do? You must use this then. Or else the formula is already provided in MF19, you can use that too, but that is a linear one. उसको simplify करने में time लगता है. This trick works like a charm and it can help you solve difficult questions. Is this clear? First write this down कि किस तरीके से हम NC3, NC2 को generally how do we break it down? So similarly, if I ask you again, what is NC4? Yes, beta. Then N n minus 1, n minus 2, n minus 3 and divided by 4 factorial हो गए ना 4 नंबर clear? So now if I were to use the same expansion, I'll go to the plus. Now if I were to use the same expansion without actually using the NC1 and NC2, then what? What should I write in place of N? NC1 की जगह क्या लिखना चाहिए? बताओ.
N upon 1.
So can I just write an N?
Yeah.
What about NC2?
N multiplied by N minus 1.
N multiplied by N minus 1 divided by 2 factorial. Now what about NC3?
N multiplied by N minus 1 multiplied by N minus 2.
So what advantage is this giving me, sir? वो ज़्यादा अच्छा काम था आपने तो क्या मुश्किल में पड़ा?
Simplify हो गया.
नहीं. What extra advantage is this giving me?
Calculation.
What was the limit of using NC3, NC2 from the calculator?
अच्छा पर्सन पॉजिटिव का देखते हैं.
Very good. उसमें N was only a positive integer. In this case, can I say N can be any rational number? N can be positive, N can be negative, N can be in fractions. We have nothing to worry about. Is this clear or not? So the first advantage that this binomial, this form of binomial expansion gives us is that for N, I can say that can be any rational number. It can be positive, it can be negative, it can take any value that I want it to. Okay, now this is something that in A levels we do not need to worry about. वो हमेशा जब हमें N provide करेगा, the question will make sure that we are provided with N being when N being a rational number. So we do not have to worry about this part. The other two conditions with this expansion, ये आगे जाकर हमें करनी पड़ेगी.
यूनिवर्सिटी में
यूनिवर्सिटी नहीं अभी ही करनी पड़ेगी.
नहीं मतलब नॉन रैशनल नंबर का
नहीं तब भी वो नहीं आएगा.
रैशनल नंबर नॉन रैशनल से बात है.
Irrational. वो बहुत रेयर आगे जाके. Now the next thing that we need to worry about, that first term must be 1. And we are expanding it, the first term must be 1. Now this is something that the questions of A levels will not cater to, and you have to worry it on your own. Sir, rational number होगा नहीं होगा? Yes, better don't worry about the power. Power हमेशा rational होगी. Sir, first term 1 होगा नहीं होगा? नहीं. The question will not take this into account. ये इसका ख्याल आपको खुद रखना है. Is this clear? And what is the third condition? The third condition is that the magnitude of the second term, which in general is x, must be less than 1, or I can say x जो है वो -1 और 1 के बीच में होगा, वो is even obvious. So the second term, a general case which is x, उसका जो value है इसकी, if you want to apply it into practical situations and scenarios, the value of the second term must be less than 1. इसके पीछे वही logic और वही concept है sum to infinity वाला. Sum to infinity में we keep expanding और आगे वाले terms नहीं लेते. This way we apply the same concept. Hence we say that the second term must be, इसका magnitude जो है that must be less than 1, or I can say the second number must be between -1 and 1. Is this clear?
But zero नहीं
Zero होगा तो फिर expansion carry पर तो 1 ही बचाना बेटे. We are left with the value 1, but no need of an expansion then. Is this clear? Now let's go to very quick examples. Okay, class. करो शाबाश. Yes, Bashir. Can you expand this? This is what you must end up getting. I want you to expand till x cube. Now, because n is not a positive integer, we cannot limit our expansion to a particular number. ये expansions चलती ही जाती हैं हमारे पास. Can you tell me the simplified answer, anyone? Yes. 1. And then -2x. And then 3x square. Minus 4x cube. Is this what everyone is getting? I want everyone to simplify it on your own. And then let me know what is actually troubling you. Out. हाँ बच्चों, what is one thing that we particularly need to worry about? एक तो वो पूछता है हमसे कि क्या इसकी लिमिटेशन होनी चाहिए. वो हम बता सकते हैं magnitude of the second term must be less than 1. What is the one thing that we need to worry about? Because the first term must be 1 or else this expansion is not valid. I mean, this one is the first term 1. 2. So what will we do? How will we make it 1 then? Very good. How can we take 2 as common if the entire bracket is a power of -1? नीचे ले आएंगे और see, I'll just go step by step. It's very easy to not worry. Do this. I've taken 2 as common, but the entire bracket still has a power of -1. इस तरह की common लेना you must have done in completing the square ASP1 maybe. Is this right or wrong? सही है गलत है? Then what? Because दोनों multiply हो रहे हैं and both have a power of -1. Can I just say that ये लिख सकता हूँ उसको मैं? 2 to the power -1 is 1/2. Okay, so now we can just expand the part we need to and we'll multiply the entire answer by 1/2. Obviously, we cannot expand until the first term is 1. Expansion valid नहीं है. There. Tell me what is the simplified answer that you get. I know it sounds a bit lengthy, but it's something that we eventually have to do. The working is not difficult. There are no big numbers involved, no complicated calculations involved. But yes, it is lengthy. I know. I understand it. नहीं, this topic is there to teach you composure, how to deal with lengthy problems. So stay calm and calmly attempt the entire question. हर चीज को have a look at every term very carefully before expanding it. Practice. बोलो दोबारा देखो तो गड़बड़ हुई है. This will end up, what do you get the second term? X upon 4. When I'll take 2 common, तो 2 दोनों में से common लेंगे ना. When I take something common, everything divides by that particular value. Is that right? So this should give me 1 over 4x. And similarly, what should this give me? 1 over 16 x square. करो simplify से पता चलेगा why. Because 1 over 4 is also being squared. This will be 1 over 16. And this fraction will just cancel out. Is this clear?